All right. So this question says, given that the equation 4x squared minus k plus 2 times x plus k is equal to 1, and it has two distinct roots, it's asking us to find the range of value of k. All right, so it gives us an equation and asks us to find the values of k that will make the roots be real and different. Now the roots are real and different when b squared minus 4ac is greater than 0. That's the discriminant. And so to tackle this question, first we have to do it is put it in its standard form. So put it in its standard form by writing it as 4x squared minus k plus 2 times x. So I have to write k plus 2 times x plus, now right here now, you're going to bring over the 1 to put it as plus k minus 1, plus k minus 1, and now that is equal to 0. All right, now this is equal to 0. So now we have a quadratic equation in its standard form, where 4 is the coefficient of x squared, minus bracket k plus 2 is the coefficient of x, and k minus 1 is our constant. So the range of values for when the roots is going to be real and distinct is when the discriminant is greater than 0. So the discriminant, remember, is b squared minus 4ac. This is when roots are real and distinct, when the discriminant is positive. All right? And so in this case, our b is minus of k plus 2. So we have minus of k plus 2, and we're going to square that, minus bracket of k plus 2, and we're going to square all of this. So we're squaring minus of k plus 2, and then we're subtracting minus 4 times a. 4 times a is 4, a is 4, and c, what is c? C is the coefficient of our constant, which is k minus 1. So we have k minus 1, and that is greater than 0. K minus 1, and that is greater than 0. All right? And so that's how we tackle this question now. So let's simplify and work this out now. So let's work this out. So in working this out, what we're going to notice is that when we square this, we're getting k squared. We're going to get k squared minus, but then k squared plus 2k times 2, and that's 4k plus 4. Now, you might wonder where all the negative gone. Now, anytime you square a negative number, you're going to get a positive result. So it's like I can ignore this negative. All right. Then I have minus. Now, 4 times 4 is 16, and 16 times k is minus 16k. So that's what I'm getting. And then I have minus 16 times negative 1, that's plus 16. I have plus 16, and that is greater than 0. That's greater than 0. So now what we have now is, we realize that we'll get back a quadratic. This is just a quadratic with k squared. Now 4k minus 16k, that's minus 12k. That's minus 12k. And then right here, so now we have 4 plus 16, that's 20. So we get plus 20, and that's greater than 0. That's greater than 0. Lovely. So that's what we're getting. Now, when we get to this stage now, you're gonna wonder, so how do I know the solution for this now? Well, first I want you to do is first factorize this. All right, so let's factorize this first. If we were to factorize k squared minus 12k plus 20, it would be k minus, now which two number with times it will get 20, but add them will get 12. That looks like 10 and 2. So it's going to be k minus 2 times k minus 10, and this is greater than 0. That's greater than 0. So now we want to know what's the solution region now. So how do we find the solution region? So to find the solution region now, I always like to picture a graph in my head. If I were to picture a graph in my head, all right, so let's say we have some quadratic looking like this, and this is the k-axis. The roots would be 2 and 10. The roots would be 2 and 10. All right, so when k equal 2 and when k equal 10, those would be the roots of this quadratic. Now, what you notice is what we want the solution is when it is greater than 0. So we want when the quadratic is greater than 0. The quadratic is greater than 0 for these pieces. These are the handles for when the quadratic is greater than 0. And so the solution is, this is the answer, k is going to be less than 2. K has to be less than 2, or a next solution is that k has to be greater than 10. All right, that is when we're going to get two real and distinct roots. All right, so this is the solution. K is either less than 2 or k is greater than 10. And you can check it. You can check it by trying a value for k, like 11, 12, 13. You can try 1, 0, or any number, and you're going to notice that you're going to get two different roots when you try k being a number less than 2, or when you try k being a number greater than 10. So that's this question. Easy, soft. All right. Now question 2 says, find the values of p for which the equation x squared minus 4px plus p is equal to 0 and has equal roots. Now, a quadratic equation has equal roots when the discriminant is equal to 0. So a quadratic equation has equal roots when the discriminant is equal to 0. Just want to write that down. So a quadratic equation has equal roots when the discriminant is 0. All right, that's when the quadratic has equal roots. Now, looking at this now, x squared minus 4px plus p equals 0. Now, the discriminant right here would be minus 4p squared. This is a discriminant, minus 4p squared minus 4 times a. B squared minus 4ac is discriminant. In this case, a is 1. So put minus 4 times 1, and c is p. And we're solving this equation equal to 0. In solving this equation equal to 0, minus 4p squared, that's going to work out to be 16p squared minus 4 times 1 times p is minus 4p, and that's equal to 0. So now we have 16p squared minus 4p equals 0. To solve this equation now, what we can do is factor out 4p. So let's go ahead and factor out 4p. Factoring out 4p, we're getting 4p left back here. So left back with 4p, and then minus 1. And that's equal to 0. Now when we get to here and we have 4p times 4p minus 1 equals 0, then either 4p equals 0 or 4p minus 1 equals 0. All right, so we have 4p equals 0 or 4p minus 1 equals 0. So to solve this, we're solving 4p is equal to 0. So we're solving 4p equals 0 or 4p minus 1 equals 0. Now solving these two equations, clearly what we're going to see is that p is equal to 0 from this side, or p is going to be a quarter. P is a quarter. All right, so these are the two possible values for p for when the function will have equal roots. All right, so let's check it out. We can always test our solution. So for example, when p is 0, the equation would be, so we're just testing the solution. When p equals 0, what we're getting is, the equation we get is just x squared minus 0 plus 0 equals 0. So when p is 0, we get the equation x squared equals 0. Nice. But look at this now. X squared equal to 0. If you were to solve that, you're only just going to get x equals 0 repeated. You're only going to get x equals 0 and x equals 0. Right? And so clearly what we can conclude, when p is 0, it has repeated root. So you can try the same for when p equal a quarter. Now this is just a test. You don't need to have this. All right? That's not needed. So this is not needed, and so we don't need to have that. But I was just justifying with you that the solution is p0 and p is a quarter. Nice. So that's when this quadratic equation has two real and equal roots. All right. Now, this question now says, show that the curve lies above the x-axis. Now, there's two ways to show that the curve lies above the x-axis. The two ways that you can show that is, let's look at method 1. So method 1 is, you can complete the square and sketch the graph. Show that the lowest point on the graph is above the x-axis. All right, so this is method 1. All right. Now we know that the x value at the turning point, xt, is going to be equal to x value at the turning point minus b, which is minus negative 2 minus b over 2a. So it's minus 2 over 2a, which is 2. And that works out to be 1. So the x value at the turning point is 1. Now when x equal 1, we're going to get the y value at the turning point is equal to 1 square. We're going to put in x as 1 now. We're going to get 1 square minus 2 times 1 plus 2. All right, and so this works out to be 1 square minus 2 times 1 plus 2. That works out to be 1. And so the turning point is 1, 1. So the turning point is 1, 1. So 1, 1 is the stationary point. 1, 1 is TP. TP means turning point. So since 1, 1 is the turning point, we can sketch this graph. Look how we're going to sketch this graph. If 1, 1 is the turning point, this is what the graph looks like. We have our x-axis and our y-axis. Let's look at it. So let's say this is the y-axis. Arrow going the wrong way, but let's try to put it in the right way. All right, it's not going in the right way. So this is our quadratic, right? And look what the question tells us. All right, x squared minus 2x plus 2. It cuts the y-axis at positive 2 and it turns at 1, 1. So let's say this is when x is 1, and let's say this is when y is 2. All right, so we know it cuts the y-axis at 2 and it turns at 1, 1. So let's say this is when y is 1. So this is what we have. We have the turning point right there, and the graph looks something like this on that side, and something like this on this side. So clearly this quadratic is completely above the x-axis. All right, and so this quadratic is completely above the x-axis. That is method 1. Now, how would you do it with method 2? Method 2 is using the discriminant. So method 2 is using the discriminant. Method 2. So when the discriminant is negative, then there is no real root, and hence curve is above x-axis. So this is what we're going to have to show. We're going to have to show that when the discriminant is negative, there is no real root, and so the curve is above the x-axis. So let's work out the discriminant. The discriminant is b squared minus 4ac. B squared minus 4 times a times c. Now, if this discriminant is negative, then we can say, yes, the curve is completely above the x-axis. So again, we look at our coefficients. B is -2, A is 1, and C is 2. So we're getting B squared minus 4AC is going to be -2 squared, minus 4 times A times C. -4 times A, which is 1, times C, which is 2. Now look at this. -2 squared is 4, and 4 minus 8 is -4. Now -4 is clearly less than 0. And since -4 is less than 0, then what we can conclude is that hence, since the discriminant is negative, there is no real root. And since there's no real root, hence the curve is above the x-axis. So you can either draw it by showing them with the turning point. You can show them the turning point. Or what you can do is use a discriminant. All right? I would go with just using discriminant. Easy, soft. Now let's look at question 4. Question 4 says, find the range of values of P for which the graph lies completely above the x-axis. So we want to find when this graph will lie completely above the x-axis. Now this graph, again, we just looked at it, we said a graph will lie completely above the x-axis when the discriminant is negative. So all we're required to do is set that this right here, we're going to set P minus 4, this is our discriminant. Whenever the discriminant b squared minus 4ac is negative, that is when the graph is going to lie completely above the x-axis. So we have P minus 4 squared minus 4 times A is 1, times C, minus 4 times 1, times C, which is also 1. When that is less than 0, and that is less than 0, then what we know is that the curve is going to lie completely above the x-axis. And so what we're getting is when we expand this, we're going to get first term square. So we get P squared minus twice the product of the two, which is minus 8P, plus second term square, which is plus 16. And then we're going to have minus 4 times 1 times 1 is minus 4, and that is less than 0. All right? And so what we're getting now is we're solving the equation P squared minus 8P. And now what we get now is 16 minus 4, and that's positive 12. That's positive 12. And that is what? That is less than 0. Voila. Nice. Lovely. And so what we get now is we can factorize this. We can factorize this quadratic expression in terms of P. So let's factorize it. So we're going to factorize it. And so what we're getting is, which two numbers when we multiply them, we get 12, but when we add them, we get 8. That looks like 6 and 2 to me. I'm going to put 6 and 2, P, P. Signs are the same, both of them negative. So minus and minus. So now if I were to just do a sketch with a p-axis, if I were to do a sketch with a p-axis, the roots would be 2 and 6. And that is when we were solving this equals 0. If we were to solve the equation equal to 0, we would get p equal 2 and p equals 6. But the solution we want is we want the solution for when this equation is going to be less than 0. This equation is going to be less than 0. That means below the x-axis. So we want when the curve is below the x-axis. And so it's going to be in here. It's going to be in here. And so what we can conclude then is that P is going to be between 2 and 6. So P is greater than 2 and P is less than 6. And that's the solution. Now you can always test your solution. For example, if you were to try P equal 4, put P equal 4 right here. 4 squared. Like, let me just write it, just a test. We're using a number between 2 and 6. So if you were to test it with a number like 4, right? 4 is between 2 and 6. If you use 4 right here, you get 4 squared minus 8 times 4 plus 12. And I tell you that that's less than 0. If you test it with 4, we're getting 4 squared minus 8 times 4. And minus 8 times 4 is negative 32 plus 12. When you add 12 to that, you're getting, that's 4 squared is 16. 16 plus 12 is 28. 28 minus 32, and that's negative 4. And look, negative 4 is less than 0. So this is just a test. All right, so this is just showing you that no matter, once you have a value of P that's between 2 and 6, this equation will be less than 0, and hence the roots or the curve is going to be completely above the x-axis when P is between 2 and 6. So that's our solution region. Very easy, soft with a capital T. All right, lovely. So that's the solution. Let's look at question 5. Question 5 is asking us to find the range of values of C for which 12x squared minus 36x plus 4c is greater than 9. So find the ranges of values of C for which 12x squared minus 36x plus 4c is greater than 9. All right, so we're going to solve this equation. Cool. So to solve this equation when it is greater than 9, well, first and foremost, if you were to just bring over the 9, you end up with what? You end up with a quadratic. So we just get 12x squared minus 36x plus 4c minus 9 plus 4c minus 9, and we'll get that that is greater than 0. Nice. Now, when we're solving a quadratic when it's greater than 0, what do we know? What we're pretty much saying is that we want when the quadratic is completely above the x-axis. Anytime you're solving a quadratic equation greater than 0, we want when it is completely above the x-axis. So this is asking us to find the ranges of values of x that will make this curve completely above the x-axis when it's greater than 0. This curve is completely above the x-axis when the discriminant is negative. So what this question is saying is, I'm translating what this is saying. So find values of x, for which the curve is completely above the x-axis. completely above x-axis. That's what this question is saying. Once you see greater than 0, it means above the x-axis. When you say less than 0, it means below the x-axis. So let's do this question now. So to tackle this question, what we're pretty much saying is that we're solving b squared. B, remember, is the coefficient of x. So what we're solving then is b squared, which is negative, let's choose red. All right, that's good. Purple. So we're saying negative 36, negative 36, negative 36 squared. That's b squared minus 4 times a, and a is 12, times c, and c is 4c minus 9, and that's greater than 0. And c, which is 4c minus 9, we're solving when this is greater than 0. All right, very easy. And so we just need to work this out in our calculator. So 36 squared, what we're getting is 1,296. So 1,296 minus 4 times 12. So 4 times 12 times 4c. 4 times 4 is 48 times 12, that's 192. And so we're subtracting 192c. So we're subtracting 192c, and then we'll go 4 times 12 times negative 9. So 4 times 12, as we know, that's 48, and 48 times 9, that's 48 times 9, that's 432. Just checking with the calculator, and the minus give us plus. So we get plus 432, plus 432, and that's indeed greater than 0. All right. So now we're solving this now. What we end up with is saying, we have 1296 minus 192c plus 432 is greater than 0. And so what we can do now is, let's bring over the 192c to the other side. So 1296, so we're adding this part, 1296 plus 432. If I were to add those, what I'm getting is, I'm getting 1,728. So 1,728, I know that that is what? That is greater than, if I bring over the 192c, bring it over here to get 192c. So all I need to do now is divide both sides by 192. So I'm going to divide both sides by 192. So let's divide both sides by 192. And so what we're getting for the solution is that c, because this 192 cancels this 192. And so what we're saying ultimately is that c seems to be less than 1728 over 192. And that is 9. And so c is less than 9, or 9 is greater than c. The proper way you'll see most people write the solution is, we generally like to put the 9 first. So we generally like to say c, generally like to see people say c is less than 9. All right, so that's that solution. Soft with a capital T. Too easy. So that's the range of value for c for when the curve is completely above x-axis, right? So find the ranges of values for c for which the curve is greater than 9. This is the range of values for c. C is less than 9. Easy. All right, let's check out this question now. Now this question says, find This question says find the ranges of values, find the range of values of x, find the range of values of m for which the roots of the equation are real. Now, what do we know about when the equation of our roots are real? So we know that the roots of the equation are real when b squared minus 4ac is less than, when it's greater than 0, we know that the roots are real and different. And when it's equal to 0, we know that it is, when it's equal to 0, we know that it is real and equal. And so now when it just says real, we know that the roots of the quadratic equation, are real when the discriminant is greater than or equal to 0. So let's write that down. So the roots of a quadratic equation, the roots of a quadratic equation are real when the discriminant is, the roots of a quadratic equation are real when the discriminant is positive. But when the root of is positive or equal to 0. All right, so that's when the roots of a quadratic equation are real. When the discriminant is positive, we're going to get two real and distinct roots. But when it's equal to 0, we get a real but equal roots. All right, and so what we're virtually saying is x squared, the coefficient of A is 1, the coefficient of B here is 3, and the coefficient of C, or the constant, is 4, and that's equal to mx. We first need to put this in standard form. So we have to put that in standard form to say x squared plus 3x minus mx minus mx. So it's 3x minus mx plus 4, and that's equal to 0, plus 4, and that's equal to 0. So that's what we have. Now, when you get to this stage, you need the coefficient of x. So we're going to have to factorize. We're going to have to write x squared plus, we have to factor out x here. So factor out x, we get 3 minus m times x plus 4, and that is equal to 0. All right. Now, we want when the roots to be real. And so it's real when the discriminant is greater than or equal to 0. So we're solving when 3 minus m squared and 3 minus m squared minus 4ac, which is 4 times 1 times 4. And we're solving when that is greater than or equal to 0. You have to put the equal to, greater than or equal to 0. All right, so now let's go ahead and solve this inequality. So to solve this inequality is very, very, very simple. All we have to do is expand this square up here to say first term square, which is 9, minus twice the product of the two, which is minus 6m, plus the second term square, which is plus m squared minus 16. And that is greater than or equal to 0. All right. Now, after we get this now, we're going to get m squared minus 6m, and then 9 minus 16, 9 minus 16, 9 minus 16 is negative 7. So we have m squared minus 6m is greater than or equal to 0. So all you have to do now is factorize. So we're going to factorize this this right here, and that is greater than or equal to 0. And so what we're getting is m, this is 7 and 1. Signs are different, the greater one negative. So put the minus here and the plus here. So now when we get to this stage, we need the solution for when this inequality is greater than or equal to 0. Now I always like to just do a little sketch in my head. If I were to just do a little sketch with an m-axis, this is an m-axis, then the roots will be, that's -1 and 7. -1, and this root would be 7, right? This would be 7. Now, all I'm saying then is that they want the solution for when the function, for when this quadratic inequality is greater than or equal to 0. So they want these portions of the graph. They want that portion. So they want the portion where, so the solution is when m is going to be less than or equal to -1, or the next part of the solution is when m, why am I using the blue color? Go back to the brighter one. Right here, in the brighter one, or when m is greater than or equal to 7. So that's the solution. Easy, soft. All right, nice.